In Chapter 2, we introduce the idea of using rates that are given in a problem and perhaps some giant ones. Those are just monomials, expressions that equal to 1. The value in the numerator and the value in the denominator are the same to solve problems. The nice thing is oftentimes when we write these things down, the problem literally tells us how to solve it. Like it basically guides us through what has to happen. So we're going to look at a few examples, things that were in what this problem was in the classwork. And then we're going to also go ahead and look at some of the problems that were in the homework. Some of the homework problems you can do in different ways, but I want to focus on doing them from this unit rate and giant one perspective. So let's start with question 80. A leaky faucet drips 1 fluid ounce of water every 5 minutes. Stop. That is a rate that's embedded in this problem. So I'm going to write that down as one of the things that I see here. So it says 1 fluid ounce, and that's abbreviated FLOZ, 1 fluid ounce of water every 5 minutes. How many gallons of water will leak from this faucet in 1 year? Okay, so what they're asking us to do is to go from one set of units uh, to another set of units, right? And we're going from fluid ounces, and they want us to get that to gallons. And the other one is minutes. We want that to get to years. So I like to do, when I have problems that involve both time and another dimension, I like to do them kind of separately. So I'm going to start by go ahead and converting. Let's do the time first because I know most of the giant ones that are involved with time. So I'm going to start by writing 1 fluid ounce, FLOZ, per 5 minutes. And my goal is to get to years. So I'm just going to start scaling these up with some values of 1 that I'm aware of. For example, I know that there's a relationship between minutes and hours. Now I can see that my minutes are embedded here in the denominator, and because of that I want minutes to live in the numerator, because again my goal is for minutes to be eliminated, right, and to go to a new measure of units, which is in this case I'll go hours, HOUR. And I know that 60 minutes is equivalent to 1 hour. So that's my first giant one. I'm just going to keep going and then we'll see that our units cancel. Now I'm living at hours and I want my hours to be eliminated as a unit. Again, my goal is to get to years. And I can see that I have an hour in my denominator, so I'm going to put hours in my numerator. And when I do that, I can go to days because I know that 24 hours is equal to 1 day. And then finally, one more giant one I can multiply, and that has to do with days in my numerator. So I've got days in the top, and I want my days to be eliminated with the days that were in the bottom. So that's why I put days in the numerator, and then I have here a year, and I know that there are 365, actually a little bit more than that, right? 365 days in a year, but we'll go ahead and we'll just leave it at 365. At this point, right, you can see my units are doing everything they need to do. The first thing I notice is that yes, my minutes are eliminated. The next thing I can see is that hours is going to be eliminated. And then finally I notice that days will be eliminated. So what ends up happening is if I just focus on the units alone, right? The units of this answer are fluid ounces, FLOZ, per year. So I've totally changed my time unit from fluid ounces per minute to fluid ounces per year. Now, as far as the calculations go, I can see in my numerator I've got a value of 1, I've got 60 minutes, I've got 24 hours, and I got 365 days all in the numerator. The only number I have in the denominator, because this is a 1 also, is 5, right? 5 times 1 times 1 times 1. So here's the arithmetic I have to do for the numerical value. I've got 1 times 60 times 24 times 365. And in my denominator, I've just got simply 5 times 1 times 1 times 1. So if I do that arithmetic, I believe I have 5 5,000, no, I'm sorry, 525,600 fluid ounces per 5 years. And if I divide that by 5 and express it as a unit rate, we end up getting 105,120 fluid ounces, FLOZ, per year. So this is now where I'm going to begin for the next part of this problem, right? I've got fluid ounces per year, but we don't want to leave our unit of volume in fluid ounces. We want to get that to gallons. So now I'm going to do a similar thing for the gallons, and I've written some giant ones. These are in our textbook in this section, and you can look these up and have some written down. Most of the ones that are kind of like unknown or unique, I will either have on a whiteboard or I will actually print on the test so that you can refer to those. But ones that involve time, some common ones like feet, inches, I expect that we kind of know most of those. But let's go ahead and move from fluid ounces per year into gallons per year. So the first thing I want to get rid of is fluid ounces. So this time I notice that my fluid ounces units is in the numerator, and I want that to leave, so I'm going to put fluid ounces in my denominator. So FLOZ, fluid ounces. And I'm going to go to cups. So I'll put, and actually here we go, that 1 cup is the same thing as 8 fluid ounces. And again, I'm just reading this from the up above here. This is a giant 1. It's equal to 1, just like all my units for time above. Next thing I want to do is I want my cups to go away. So now cups are in the numerator. To eliminate them, I'm going to put cups in my denominator. And I've got 4 cups is equivalent to 1 quart, Q-U-A-R-T. And then finally, my last one, quarts, I need to eliminate, Q-U-A-R-T. And it turns out that 4 quarts is the same as 1 gallon. So if we look closely at what's happening here, right, our fluid ounces will be eliminated, cups will be eliminated, and quarts will be eliminated. And the only thing we're going to be left with is gallons and per year. So we've got gallons up here, and we've got our time unit down below is per year. So now it's just a matter of doing arithmetic, and I'm going to use a calculator. But I know that the units for my answer are going to be gallons per 1 year. In my numerator, I can see I have this very large number. This is the number 1. So I've got 105,120 times 1 times 1 times 1. So the only number in my numerator is 105, 120. And in my denominator, I've got 1 times 8 times 4 times 4. So I'll just go 8 times 4 times 4, which is 16 times 4. 8 times 4 times 4 is 128. So this is 105, 120 divided by 128. And if I turn that into a unit rate, 105, 120, and I'm just going to divide by 128. So as a unit rate, we're looking at 821 and a quarter gallons per year. So again, this process, the nice thing was I didn't really think about I didn't have to think about when do I divide, when do I multiply. I just set it up so that the units canceled, and when I did that, it told me what to do, right? I could see in the numerator and denominator how things would be eliminated. All right, so let's look at a couple more examples. So this is question 82 from the same section, and I have a record. I keep composition notebooks of every single time I've done this problem. And when I first did this problem many years ago, I was focused on not really thinking about rates in the problem in giant ones. I was focused on formulas and how to plug things into a formula because I didn't really understand this concept as well. My chemistry teacher would not be happy with me, but it was something I struggled with. Now it seems so much simpler that I understand what's going on. So I just want to share with you how I would think about this problem now. So a car gets 25 miles per gallon. That's a rate. I heard it, something per something. So I'm going to write down that rate. So we're going to start with the fact that the car is going to get 25 miles per 1 gallon. Okay, so this is a rate that's given to me in the problem, and I just write it down. Right, this is from the problem. This is not a giant one. It's clearly not the case that 25 miles is the same thing as a gallon. However, in the context of this problem, yeah, 1 gallon of gas is getting me 25 miles of travel. So there is kind of an idea of it, of if it's their equivalent, but this is from the problem, and this can vary. This is not always the case. It depends on your car and your driving situation. The next thing it says it travels for 45 minutes. That doesn't sound like a rate. It travels at 45 minutes at 65 miles per hour. Okay, that is a rate, right? So there's another rate here, 65 miles per 1 hour. So I've got two rates that are given to me in the problem. One is 25 miles per gallon. The other one is 65 miles per hour. The other thing this problem tells me is that my travel time is I am traveling for 45 minutes. N-U-T-E-S. How many gallons of gas does the car use during this time? So these are both giant. These are not giant ones. These are both rates, right? This is a rate and this is a rate. And these rates are given to me in the context of this problem. And also they're giving me this other quantity, and it is time, right? But this is just given that we're given 45 minutes of travel. And what we want to get out of this is a number of gallons that we're going to consume. So it says show work using units and giant one. So what I'm going to do is I'm going to start with the fact that I'm traveling for 45 minutes. Now, that is not minutes per anything, right? It's just 45 minutes. And when I look at my problem up above, none of the two rates that I'm given from this problem involve minutes, right? One is miles per gallon, the other one is miles per hour. However, I am looking at the dimension of time, and I can see that I have hours in that 65 miles per hour. So what I'm going to do is I'm going to introduce a giant one that I know to move my minutes into hours. So again, I'm just multiplying this 45 minutes per nothing. It's just one, right? 45 minutes over one. And I'm going to multiply that by something that will eliminate the minutes and give me hours. So here comes a giant one. I know that I can put minutes in my denominator, and I can put hours in the numerator. Now, an hour is not the same thing as a minute. However, 1 hour is the same quantity as 60 minutes. So here's the giant one, right? I'm multiplying by an equal amount of time over equal amount of time. So I'm not changing the amount of time. I'm just working on changing the units. And in fact, I'll highlight it. My minutes are gone, right? And now I'm just looking at, instead of 45 minutes, this is a new measurement, but it's hours, right? And the fraction is 45 over 60, but I don't care what that number is right now. I'm still trying to finish this problem. Okay, so now that I've got hours, I can eliminate the hours. I can make the hours go away, and I can turn this into miles. And the way that I can do that is by bringing in this second rate, right? This second rate, which has hours in my denominator, and I've got hours in my numerator right now, so this is going to be perfect. I'm going to go ahead and put 65 miles, M-I-L-E-S, per 1 hour. So if we look now, right, my hours are being eliminated. And now, what am I looking at here? I'm now looking at miles. So I've gone from minutes to hours, and now I'm looking at miles. So I've turned minutes into hours, and then now I'm turning hours into number of miles by multiplying by this rate from the problem. And then the final rate that I'm going to do is my fuel consumption ratio. My fuel consumption was 25 miles per 1 gallon. What I notice this time is that miles in that are in my numerator, and I've already got miles in a numerator. So instead of multiplying by 25 miles per 1 gallon, I'm going to write the reciprocal of that, which is still true, right? I can say multiplied by 1 gallon per 25 miles. And I can see on this final step that my miles are eliminated with these miles. And what I'm looking at now are gallons, right? So I've literally gotten to a place where I can say it was asking how many gallons does the car consume? Well, that's how many. And I'm not worried about, what arithmetic to do. It tells me what arithmetic to do. But I do know this right off the bat that the units of this answer are gallons because those are the only units left in this problem, right? Gallons are my only units available. So I'll go ahead and write here, these are gallons. And how many gallons? Well, in my numerator, I've got 45 times 1 times 65. Obviously, the one's not necessary. And in the denominator, I've got 1 times 60 times 1, which is, I'm grabbing a calculator, 45 times 65, which is 2,925. 2,925 divided by 60, which gives me, oh, I'm missing one of my units, aren't I? I forgot this 25. Mr. Roberts, that's so goofy. Yeah, I need, there's another 1 times that gallon, but also there's another 25 that lives in the denominator. And this problem tells me what to do, but I've got to listen to it. I guess I should look more carefully. 45, 1, 65, 1, 160, 125. So when I finally get all the right numbers in there, including the 25, I get 2925 divided by 1500, which is 1.95 gallons. So in 45 minutes, given that my car is consuming 25 miles, my car can travel 25 miles per gallon, and I'm going at a speed of 65 miles per hour, I would consume 1.95 gallons. Again, dimensional analysis. I'm using giant ones and rates from a problem to solve them. We're going to look at one final example. Problem 29 is pretty straightforward, but I think we should take a look at it as well. So the first rate I'm given here, and they do a lot to define what prime time is, and there's numbers there, but they really don't have much to do with the problem. All I know is that if I buy 1 minute, a 1 minute ad during this special time, it will cost me $12,800. And the question says, how much does that cost per second? Oh, I'm just going to have to use a giant one here. The problem only gave me the one rate. The one rate was a minute for a minute cost 1,000, no, $12,800. And I'm just going to introduce the giant one to eliminate minutes. So I'm going to put minutes in my denominator, and I'm going to put seconds in the numerator. And that does not equal 1, right? A second is not the same thing as a minute. However, 60 seconds is exactly the same amount of time as 1 minute. So you can see I've now got a 1 that I'm multiplying by. So I'm not changing the quantity or the rate, I'm just changing the units. My minutes will eliminate with minutes, and now this answer is going to be how much it'll cost per second. And if I do the arithmetic here, it's going to be seconds per dollars. So I guess this was a good example to look at, because when I do this, I get the 60 seconds in the top and the 12,800 in the bottom. That can reduce to 3 per 640, but they're asking, to the nearest cost per second to the nearest cent. So I really need the reciprocal of that, and I can write that. I can just go ahead and say, I can say 640 over 3, so it's $640 per 3 seconds. And then I can convert this in my mind more easily to a unit rate by just taking 640 divided by 3, and I get that it is $213.33. So this should be my answer. 1 second cost $213.33. A recommendation is that you jump through the remaining sections of the chapter and find and highlight the problems that involve rates and giant ones, and go through and review those for the our test that's coming up. So again, go through the rest of the chapter, find those problems that use these ideas, and kind of go through and make sure you understand what's happening with those.